Assalamualaikum and good morning to the respected panel's member and my supervisor. My name is Muhammad Asfar bin Muhammad Azhar, and today I will be presenting my final year project proposal entitled Design and Stability Evaluation of Modular Flood Relief Boot Hull Forms. As we all know, flood disasters have become increasingly frequent in Malaysia, creating a need for efficient rescue vessels that can operate in shallow and flooded environments. This project focuses on designing modular flood relief boats and evaluating its hydrostatic and stability performance to ensure safe and effective rescue operation. We are moving to introductions. In Malaysia, floods are among the most common natural disasters in Malaysia and occur almost every year, especially during northeast monsoon seasons. During severe flooding, roads become inaccessible and boats become the primary means of transportation for rescue teams. However, the conventional rescue boats often face challenges because they are difficult to transport quickly to disaster area and may not perform efficiently in shallow or debris-filled water. To overcome this challenge, a modular boat system has been proposed as an alternative solution. Modular boats can be separated into smaller sections, making transportation easier and allowing rapid assembly near the rescue locations. In addition, a rescue boat must possess adequate buoyancy and stability to ensure the safety of rescue personnel and flood victims. Therefore, this study focused on developing a modular flood relief boat hull form and evaluating its hydrostatic and stability characteristics. Moving on to problem statement, in the slide this slide presents the main issue that motivate this research. Firstly, most existing flood relief boats do not use a modular hull configuration. This makes transportation and deployment difficult, especially when disaster areas are located in remote locations with limited access. Secondly, the stability of rescue boats can change significantly when different payloads are carried on board. For example, the number of passengers, rescue equipment, fuel, and supplies may vary from one mission to another. Thirdly, many existing rescue boats are not specifically optimized for shallow water flooded environments. As a result, there is a need to develop a modular hull architecture that can improve portability while maintaining adequate hydrostatic performance and stability. This project addresses this issue by proposing a modular flood relief boat and evaluating its performance under different loading conditions. Moving on to objective, this project has two main objectives. The first objective is to design the conceptual parameters and hardship, also known as the lifespan of a modular flood relief boat using computer-aided design software. This included determining the principal dimensions such as length, beam, draft, and hull geometry suitable for flood rescue operations. The second objective is to analyze the hydrostatic properties and evaluate the intact stability and the design hull under various loading conditions. Through this objective, the project aims to produce a book design that is both practical and safe for rescue operations. We move to the scope of work. The scope of this project focuses on the conceptual and preliminary design stage. The study includes the development of a modular segmented hull configurations intended for shallow water flood rescue operations. All modeling and analysis work will be carried out using MathSurf software. This project will evaluate hydrostatic properties such as displacement, buoyancy, center of buoyancy, and metacentric height. The vessel's stability performance will also be assessed under different loading conditions and compared with the IMO intact stability codes requirements. Additionally, a parametric study will be conducted to investigate how different modular connection locations affect the vessel's performance. However, structural and strength analysis, material selection, and detailed manufacturing process are beyond the scope of this research. Moving to literature review, this slide discuss the design approach and hull form selections. The ship design spiral is well established. Methodology in naval architecture it consists of four major stages: concept designs, preliminary designs, concept design, and detailed designs. The design process is iterative, meaning the designer continuously improves the design based on the performance evaluations. This research focuses on the concept design stage because it forms the foundation of the entire vessel design process. Regarding hull form selection, a flat bottom hull is chosen for this study. The main reason is that flat bottom hull provide a shallow draft which allow the boats to operate in shallow flat water. It also offers high initial stability, which is important during rescue operation when passengers are boarding or moving around the vessel. This characteristic make the flat bottom hull highly suitable for flat relief applications. Moving on to literature review for this stability concept and similar designs. So one of the most important aspect of rescue boats design is stability. The key parameter used to assess initial stability is metacentric height or GM. The equation shown on the slide is Gm equal Km minus Kg, where Km is the distance from keel to the metacenter, and Kg is the distance from the keel to the center of gravity. A position and moderate Gm value indicates that the vessel has sufficient stability and can return to an upright position after healing. A very large GM can make the vessel roll excessively fast, while a very small GM can make it unstable. The study also reviewed two existing designs. The first is the rescue airboats developed by Kaminsky in 2013. It's performed well in shallow water and debris-filled environments, but experienced reduced stability when carrying heavy loads because of its height-mounted propulsion system. The second design is the modular portable USB developed by Ramos in 2025. Its modular construction allows easy transportations and rapid deployments, but the modular joints may increase hydrodynamic resistance and reduce performance in rough water. This design provides a valuable insight for developing an improved modular flat relief board. We continue with the methodology, research flow, and parent shapes. The methodology begins with information gathering. At this stage, operational requirements, rescue mission profiles, and relevant regulations are identified. The second step is estimating the principal particulars. Using parent sheet data, the selected parent sheet provide a baseline for determining the dimension and performance requirement of the new designs. The third step is hull generation using massive software, where the initial 3D hull model is created. The first step is involve hydrostatic calculations, which is to evaluate buoyancy, displacement, center of buoyancy, and other hydrostatic characteristics. And lastly, stability analysis is carried out to determine the vessel behavior under different loading conditions. And finally, the results are compared against the IMO's impact stability codes to ensure compliance with safety requirements. The selected parent ship has shallow draft, adequate payload capacity, and proven effectiveness in rescue operation, making it an appropriate reference vessel for this study. We are moving to the last slides, which is expected result and then conclusions. Okay, this slide summarizes the expected outcome of this project. The first expected deliver is a complete 3D hull developed using MATSEF. The second one is deliver in a line plan showing a hull geometry. This project also produced hydrostatic tables containing important parameter uh, such as displacement, draft, and metacentric height. In addition, Bonjon curve and interstability curve will be generated to evaluate the vessel hydrostatic and stability performance. In conclusions, this project aims to develop a modular flight relief boat that is portable, stable, and suitable for flight rescue operations. By combining a modular hull architecture with detailed hydrostatic and stability analysis, the final design is expected to meet the IMO safety requirements while also providing an effective solution for flood rescue missions in Malaysia. That's conclude my presentation on design and stability evaluation of modular flood relief boat hull forms. To summarize, this project aims to develop a modular flood relief boat that is portable, easy to deploy, and capable of operating safely in shallow flood environments. The proposed design will be developed using MedSurf software and evaluated throughout hydrostatic and stability analysis to ensure compliance with the IMO Intel stability codes. The expected outcome is safe and practical rescue boat design that can support flood relief operation in Malaysia. Uh, Lastly, I would like to express my sincere appreciation to my supervisor, Sir Muhammad Azhadi bin Johan, for his guidance and support throughout making this project. I would also like to thank the faculty and the evaluator for taking the time to review my proposal presentations. Thank you for watching. I hope you're having a nice day.